Chris, I'd be interested in kind of at some point during the modeling conversation, understanding how maybe the PHPP might have a potential to connect, or utilizing BIM models. Kind of, what is there sort of some workflows in development or existing where
Mhm.
we can sort of the hard work folks have already done to port them into these things?
Yeah, so I can't talk as a central person in the development of Beam now, but I'm still fairly connected with all of that, and they're working on a you know better version of the tool, so it's going to stop being a Google spreadsheet and start being a sort of web-based app. And part of the reason for that is to sort of explore that kind of connectivity um, with the software programs that people are already using. In particular, you know, this might be a segue into talking about the ResNet standard, but the reason that we went to ResNet to sort of come up with that standard is it's people who do energy modeling that are best positioned to do embodied carbon modeling, because the model is basically the same, right? We both deal with area-based models. Um, so early on with Beam, we decided not to do kind of the BIM bill of materials from an electronic plan set, because we just saw in everybody that we knew in residential practice, they might be using BIM enabled software tools, but they're not making a model that actually cranks out like this is the number of 2x4s, and this is they're not defining all of those things and building the model that way. But area is common to every model that you make. Like you can say, I have this much wall area, this much window area, this much roof area. Like that's always in there. And that's also what, a HERS modeler is doing, a passive house modeler is doing. Like we have those areas. And so, from early on, we decided with Beam, those areas would be the foundation of doing the material takeoffs. So, you give the tool the area, it's going to do the takeoff for you. And sometimes it asks you, is this on 16-inch center or 24-inch center, to be able to refine that. But by and large, the tool is doing the material takeoff based on area. And so, yeah, anybody who's already doing an area-based model is doing 80% of the work to do an embodied carbon model. And so the idea was to try to preserve that and start enabling people to import that into Beam from whatever tool they happen to be using. So um, the Beam folks have been waiting for 1550 to get published, because there's going to have to be some tweaks to the tool to make it compliant with that. But along with making it compliant with 1550 is going to come the ability to talk with other tools, and uh, PHPP being one of those.
Exciting.
Yeah. Yeah. So I guess maybe what I can do, I'm going to sort of, well, this is some work we did for a home builders association in Texas. So the sort of previous slides were, we built them a baseline model. So their builder said, this is typically what we do on a home here. So we made a beam model of that home, 30 odd tons of emissions for the things that were modeled. And then, they also told us other things that they build with. Basically, a bunch of their builders gave us, here's our specs. And so for the same home, if somebody was using a lot more of the high embodied carbon materials, that 32 tons would creep up to 40. But then there was also a few builders in that group whose sort of like natural inclination. We call these the happy accidents, because none of these builders set out to be either high embodied carbon or low embodied carbon. They just chose their products based on all the other criteria that they have. And it just so happens that, the happy accident model is around 14 tons. So, less than half of the sort of baseline model. Um, and so, this is the kind of stuff that you can get out of either doing a whole building model like this or just analyzing uh, a particular assembly, um, or really just, you know, once you're familiar with looking through a tool like Beam, like what the high and low emitting materials are. Like, you don't even really have to model anymore. It's like, if you've seen that cellulose insulation is the lowest embodied carbon insulation that's practical for you, like you don't have to run the model every time. It's going to tell you the same thing every time. So, um, if you can talk to your concrete supplier about a 40% slag or 40% fly ash concrete or something like that, it's always going to be 30% less, and you don't have to model it every time. But it is helpful to make the model to sort of see where those things are. But you don't, it's not a rapidly changing field. The EPDs that this is all based on, companies tend to update them. They're valid for 5 years. So the background data doesn't change fast or anything like that. So it's the kind of thing, if you get yourself somewhat familiar with the options, then you just know that, and you don't have to keep revisiting the tool or redoing the model over and over. Yeah, and so this was the sort of the happy accident model. In Beam, there's sort of a review sheet in the spreadsheet that kind of every product that you've picked kind of shows up, and you can see it color coded by its the assembly that it's in. And yeah, this is sort of how we iterate. You can do a baseline model and then go back and do a lower embodied carbon model and kind of put the two side by side. And I think the thing that I like to talk to people in the passive house world about is, like, it's great to do embodied carbon. You already do, the energy efficiency side exceptionally well, but it's like where those things intersect and where they influence each other that I think is going to be of interest to people who think about this stuff like passive house people do, where it's like, if you're sort of being able to iterate between a Beam model and a passive house model, you'd be able to see things like, do those triple pane windows, like, I know what impact they have on the operational efficiency. What does it do for embodied carbon? And you can actually like see those things kind of side by side and go, oh, that won't pay off for 25 years. Maybe that's not such a good choice. Or, I mean, I shouldn't pick on triple pane windows. It's just the example I came up with. But, there are all of those things. Lots of people in the passive house world are like, oh, I use spray foam because it gets me this air sealing and a great R value for the inch and stuff like that. And it's like, cool, run the model and see, like, what the sort of the payback period for that embodied carbon is. And so this little series of slides I'm going to show you is from a study we did in Nelson, where we had both the energy models and the embodied carbon models for about 35 houses that were built in the same year there. And so the first bar here is, like, on average, what we found was that the embodied carbon, which is the dark blue part of the bar, equaled the not about 20 years worth of operational emissions for the whole data set. But if you look at the number for operating emissions in Nelson, BC, at just like 1.25 tons per year, they have a pretty clean grid in Nelson, and people tend to build highly electrified homes. So this is a bit of an interesting. Not many areas would have an average like that. Go ahead, Susie. Sorry, I see your hand now.
Hi.
Hi.
So I am in Los Angeles, I'm not with Rocky Mountain, per se, but I am curious, are you working on something that will also track toxicity levels when burned? Like it'd be really, I think it's sad to say, but I think
Mhm.
it's a selling point.
Yeah.
But it'd be nice to have some data, and it looks like you guys might be the ones who could provide it.
Yeah. Yeah. That's can I segue there in a minute? Because I think it is a really important thing, but I'm just going to play out this thing because I just to sort of finish the point. Um, so in this set from Nelson, we found definitely some examples where both the embodied carbon and the operational carbon were high. So this would be, and like 5 tons a year for operating emissions in a northern climate, like that's clearly gas, but it's pretty efficient. The building codes in BC, even a minimum, is pretty good. So even what looked like a high carbon model there, um, you know, isn't necessarily compared to other regions, but so in that same data set, there were these ones with both high, embodied and operating emissions. We found a couple interesting examples where the embodied carbon was actually lower than average, which is great. That more of those happy accidents, but on the operational side, that model wasn't particularly great. So like yes, they won, a bit in terms of their embodied carbon, but it didn't matter, for the climate as a whole because they weren't really paying attention, enough on the operational side. We found this one, which had incredibly high embodied carbon, but it was a passive house. It was super efficient and, fully electrified and has almost no operating emissions. But you'll see, like, it's actually no better than average over the 20 years. Like, it's 54 tons was the average and 50.7 was the thing for this building. So all the effort that went into making that super efficient and fully electrified, because they missed the boat on embodied carbon, it's no better a building for the climate, over the next couple of decades than average. And then you know, this was one that was not a happy accident. That builder actually set out to do low embodied carbon and passive house. And, I think this is the thing that the passive house community is so poised to be able to do well because you're already doing this tiny little slice, on the operational piece. An electrified passive house is like there just is no better answer on the operational side. And if you can achieve that with this really low upfront embodied carbon piece, like what you get is something after 20 years, this building only has 16 and a half tons of emissions. That's like half of what it just took to make the average building, and you can make it and run it for 20 years on half of that. So I think that's, this is the place that I see, or I hope passive house, folks getting to because you already do this the thin slice of operational stuff on the middle. You already design efficiently from the point of view of form, and it's not you're not wasting lots of materials. And so by kind of honing in on you know both using as little material as possible where possible, and then better materials where possible, you can really sort of get to that place. And that's you know that's why it's great for people who do energy modeling to also do embodied carbon modeling, because if you keep these things separate, like you could end up with any of these three scenarios in the middle where it's like, well, I did a great job, but the person over there didn't, and so it doesn't really work out. I think folks in the passive house space are really well positioned to kind of have the lens on both of those things. And then yeah, to your point, Susie, it's the sort of link between low embodied carbon materials and healthy materials. It's one of those places where the Venn diagram almost looks like a full circle because there are very few examples where if we look at we've kind of taken the embodied carbon rankings from Beam and compared them to the material health rankings from the they were called Healthy Buildings Network. They just rebranded to, I forget what they rebranded to. But anyway, they have a system for rating the health impacts of materials, and embodied carbon and health track almost perfectly in almost every case, where the low embodied carbon material from the Beam database is also the healthier material from the HBN uh, from their work. And those two things, circle together really well. I think in general, they circle together well because petrochemicals and petrochemical, like the processing of petrochemicals into building products, is one of the things that has really high embodied carbon. It takes a lot of energy to transform petrochemicals into the various things that turn them into building products. And that tends to cause a lot of not just carbon emissions, but other kinds of greenhouse gas emissions, quite often ones that are a lot more potent than CO2. And so, and petrochemicals are what tend to make materials unhealthy, tend to make them burn in really crazy ways and give off, really horrible byproducts when they are burned. And so, yeah, I think you're really onto something, that there's a close link there, and that's something that I would love for me and others to sort of explore and make that a more formal kind of link, because I think it's a great thing where maybe your client isn't about climate or embodied carbon, but not very many clients aren't about health in some way. And so if you can bring them the healthier material, and it just happens to be a much lower embodied carbon material, like that's a great kind of win-win that you can sort of bring to the table.
Hey,
Thank
Chris, I
you.
see you used 20 years as kind of your measuring stick for this. And I hear different camps on that. But can you speak to kind of how you feel about like the immediate crisis versus the long-term kind of
Mhm.
gains, et cetera, and kind of where the sweet spot is? So
Yeah. I mean, I think to some degree we chose 20 years on this because for a couple reasons, partly because it is not the sweet spot, but the next couple decades are pretty make or break for the climate. And so, you could extend, this analysis out 100 years, and obviously the operational piece would start to really outweigh the embodied piece even on the best models. But it's like what goes into the atmosphere today is the bigger driver of climate, right? Like I think a lot of people forget that like an emission isn't a one time. It's not like, oh, we emitted this much this year, but that's okay. We'll do better next year. It's like, no, no, no. That greenhouse gas stays in the atmosphere. And if it's trapping heat this year, it's also trapping heat next year and next year and next year and next year. So, there's a high, it's really important what we do now. And sometimes like people will be like, well, I did this thing, but it's gonna like it pays off in 100 years. It's like it only pays off in 100 years if you're looking at it in a linear way, but the climate doesn't feel it in that linear way. The climate, those greenhouse gases are additive in their effect. And so I tend to take a bit of a narrow lens just because like this is these next few decades. I could have done 25 years. I could have done 30 years. I think that that window can flex, but I think it is really important to that what we do now, and even these graphs don't really show that, right? Like the climate impact of any of those dark blue bars is much, much greater than the actual climate impact, even of the big light blue bars, because it happens today and adds heat, at that rate every year moving forward, whereas each of those little 1-year emission bars, like that cumulative effect doesn't, it takes a while before it accumulates the way the upfront one does.
Great. Nathan had a question that was similar to mine. Is what is this? What is that building? We want to see that building.
Yeah, that's in at the end of the slide deck I have. There's links on the Builders for Climate Action site to that Nelson study, and so that building is in there. There's a whole bunch of case studies on our HomebuildersCAN website, so I've got some slides here on those, but you can also go, there's I think about a dozen of these case studies now, so you can go and get into those in more detail. This is one that we just published. I really like this one. It's Passive House certified. It's also multifamily, and they also did an 80% embodied carbon reduction from a typical building, and the developer was like, oh, a third of that embodied carbon reduction was cost neutral. Like, these were things that didn't cost anymore but made a big difference in the embodied carbon. And so, there was that time 20 years ago when everybody was like, Passive House, uses 90% less energy than code. And I know, like, we've sort of caught up to the place where that's not the number anymore. But in the embodied carbon space, like, that kind of jump is possible, and you can sort of see it in projects like this. Like, this is, somebody made this and they made it affordably and code compliant, and they kind of hit an 80% reduction in embodied carbon, which is pretty substantial. And I was just going to see, yeah, so I'll just maybe talk briefly about this ResNet standard. I know, feelings are mixed in the building industry about the ResNet organization, and I'm a Canadian, so I can claim, that I don't know everything about that, but they are a standards organization. They're recognized by ANSI, and so strategically for our HomebuildersCAN group, it was like, it felt like we really need a standard so that people are measuring embodied carbon the same way. That's sort of been the criticism of embodied carbon, is like, well, so-and-so did it this way and they got this answer, and so-and-so did it that way and they got that answer, and we can't ever compare anything because everybody does it differently. And so, when we went to ResNet, they were, surprisingly interested in doing this. And so I think we have a really good standard based on areas, based on sort of having energy raters be the people doing the embodied carbon, kind of leveraging all the work that people are already putting into that. It's specific to the sort of low-rise residential sector, which is it's a unique building type. And I think if you look at some of the other emerging standards for embodied carbon, they don't really fit very well with the residential sector. And so, this standard doesn't set out any thresholds. It doesn't say this is a good number, this is a bad number. It's just a way for everybody to be measuring the same things in the same way, using the same data, and trying to create a system where, if you do the work according to the standard, what you come up with is directly comparable to what somebody else would come up with. And so we public comment just closed this week. So we'll be going into the sort of next cycle of development, but hopefully this is a published standard by April of this year, and is something that then, like, the tools like Beam and hopefully others will rejig the tools to be compliant with this standard, and then we can all go about getting reasonably good answers, but definitely comparable answers, one of the interesting things that 1550 adds that a tool like Beam right now doesn't have is all the MEP equipment is included in the standard, and we did a lot of work to come up with some benchmark values. So because right now, like most heat pumps, most whatever other mechanical equipment, there aren't really EPDs or good values on that, but we came up with some really good sort of standard placeholder values so that practitioners can actually assess these things. So for wiring and plumbing and heating equipment, there are some default values. There's a table of default values in there that I think will be really helpful. The scope was included a bit. It includes some surprising things like paint, which we realized paint is often a bigger contributor than MEP equipment, surprisingly enough. So, we kind of were able to analyze like where are some hot spots that maybe a tool like Beam was missing and make sure that that was included. So I'm very happy with it. I had not gone through the consensus standard process before where you have manufacturers and builders and all of these parties at the table, but I'm really happy with what we came up with. You can download the draft standard from the ResNet site right now, the one that just closed for public comment, and you'll be able to see. I don't think much is going to change. I haven't looked at all the public comments yet, but I think by and large what you would see there now is pretty close to what's going to get published in the spring. So happy to take any questions on that, or I think we're at time, aren't we? We're close to it.
Yeah. If you have just a couple minutes and we have some questions, we'd love to hit you with them, but we understand Bogey too.
Yeah.
I think off the bat for me is, do you think there'll be any sort of databasing of this information for Passive House? There's a database of homes that have made the certification throughout the world. Will they database this in any manner is part of the question. And in some ways, I think it would be a good idea if just from a competitive nature, I already saw 16.5 T for 20 years. Like with that, what if you were to challenge us Passive House people for that 20-year mark, what should we be shooting at? And I know it's as low as possible, but what's realistic in a target?
Yeah. I mean, I would tend to give the target in terms of like intensity per square meter rather than, because part of that 16 tons was a very small house. So obviously even if that house used all the same materials but was twice as big, it would be 30. So out of the sort of 1,000 houses that we've modeled so far, 200 kilograms of emissions per square meter has been the kind of average. So anything you can do that's better than that is good. There are like lots of people now figuring out how to hit like 80 kilograms per square meter pretty reliably, with just not major tweaks, but just a few tweaks. And like you saw with that multifamily one, like what were they at 40 or 60 or something like that? You can get that low, but I would say if you can come in under 200. Now that number will change with 1550 because currently that number doesn't include MEP, it doesn't include paint. So the baseline number is going to go up. But if you were to model something in Beam today, coming in anywhere, 150 or less, you could pat yourself on the back for that.
Great. And then do you think they'll database it? Or database the results for individual structures?
That's ResNet's plan. Like ResNet has a registry, so every HERS rated building, that info does go into a database. And I think the plan is to eventually, under the HERS system, put the embodied carbon results into their database. I'm hoping that Passive House organizations will want to do the same thing. Because because I think, yeah, that would be great to be able to kind of see that on a more than, you know, 1 or 2 building scale, but to see lots of buildings.
I think with that, another one would be, are there any jurisdictions or authorities, cities, counties, states that are interested in incorporating this in their regulations that would be interesting to talk to?
Yeah, so Boulder, Colorado just put out an RFP looking for help to come up with an embodied carbon code for the city. Washington and Oregon states just had studies commissioned. Washington now has something before their legislature to sort of act on the study and put something into their code. The city of Vancouver has a program right now where you can actually get paid to make a low embodied carbon house in Vancouver. That's a pretty sweet deal. The city of Toronto, for their green standard, has an embodied carbon limit. So those things are coming. I know Austin, we've had some conversations with Austin. There's some interest in doing it there. Mass Save, which is the sort of utility group in Massachusetts, has proposed embodied carbon incentives for their utility incentive program, and the state is looking at, they're going to be putting just insulation embodied carbon into their next code, the same way Vermont did a few years ago. So yeah, it's starting to happen.
Man, that's fantastic. I'm so excited. It seems like we're at the precipice of something really cool with this.